Because infrared penetrates less than a millimeter into the ocean's surface, many skeptics argued it is impossible to blame rising CO2 for ocean warming. It is solar energy that drives the observed ocean heating. Because the sun's surface is so hot, it emits high-energy shortwave radiation. Because the Earth is so much cooler than the sun, it only emits that energy as long-wave infrared waves, which interact very differently with the Earth than the sun's short waves. While some long waves can escape back to space unimpeded and at the speed of light, other long waves can be absorbed by greenhouse gases like carbon dioxide and water vapor. Greenhouse gases redirect half that energy back towards the Earth's surface, which counteracts the rate of cooling and prevents the Earth's nighttime cooling from dropping to the point of global freezing. However, that long-wave energy is not trapped. Eventually, nearly all the energy from the sun escapes back to space. The sun's shortwave energy doesn't penetrate the soils much deeper than an inch or so. Now, greenhouse long-wave energy only penetrates a few microns into the ocean surface, and even less into most soils. But the sun's shortwave energy passes far more deeply into the ocean, to 200 meters depth. It is argued that because long-wave heating can add 100 times more energy into the skin layer than solar heating, long-wave heating can alter and even reverse the temperature gradient required for ocean cooling. But then again, if that's true, then how does the ocean ever lose heat? Nonetheless, the alarmist narrative becomes that added infrared energy must alter the temperature gradient to some degree. Therefore, as more greenhouse gases add more long-wave energy to the surface skin layer, it increasingly disrupts the temperature gradient, and enough to reduce the rate of subsurface cooling. So rising CO2 indirectly is warming the ocean. But measurements just do not support such narratives. Satellite measures determine the ocean's surface temperature by measuring the long-wave radiation emitted from the skin layer. The results show the ocean's skin layer is always cooler than the subsurface layers, despite the combined surface warming by shortwave and long-wave heating, plus rising heat from solar-heated waters below. No matter the season or time of day, the skin layer is always cooler than the waters immediately below. On average, the skin surface cooling balances skin surface heating, but the skin surface remains slightly cooler because it radiates heat away faster than the subsurface heat can rise from below.